All right, guys, so this is part 2 of the IS number 20 notes. It's about confidence intervals for P1 minus P2. So we're going to ask this different question: which gender uses Twitter more? So our problem statement says a recent sample of 200 US females revealed 110 use Twitter regularly. A separate random sample of 150 US males revealed that 60 use Twitter regularly. Construct a 95% confidence interval for the true difference in proportions who use Twitter regularly, and it specifically tells us to use females minus males, although in general, we would either have a hint from the problem, like in the last one where it said that STEM students are underrepresented, so we want to do STEM minus non-STEM, or we just use whatever is stated first as the first population. Okay, so I noticed that I have a random sample of 200 US females. That's going to be N1. And I know how to calculate P1 hat. So P1 hat is going to be that 110 of the females who use Twitter regularly divided by the total number of females divided by 200. Okay, so what's that? 110 divided by 200. I get 0.55. 0.55. Okay, so then I can calculate P2 hat by saying that I have a random sample of 150 US males and 60 use Twitter regularly. So P2 hat, so that's 60 divided by 150. Let's see what that is. 60 divided by, 150 is 0.4. I might just go ahead and write 0.40 to compare. This would be 55% of the females and 40% of the males. I can already tell I have some evidence that the proportion between males and females is different, or I even have some evidence that the proportion of females is higher, but I need to determine, I could determine whether I have convincing evidence of the test, but it actually didn't ask me for that. It asked me for a confidence interval. So we're going to do that. It says to use a 95% confidence level, and it states my parameter right here, the true difference in proportions who use Twitter regularly between females and males. So I'm ready to start my plan step. Okay, I start with my parameter. So I know it's going to be P1 minus P2 is, again, the true difference. It's always true difference, and then the context is what changes. So true difference in proportions. I'm going to abbreviate proportions. So PROP, proportions who use Twitter regularly. And again, it told me to do females minus males. Okay, so then I also state my statistic. So that's my P1 hat minus P2 hat. I know what P1 hat is. It's 0.55. And I know what P2 hat is. It's 0.40. So I get 0.15 is my difference in sample proportions. So I'm thinking, okay, between my samples, there's a 15% difference. Is that going to be, or what is my estimate now going to be for the populations? Well, something around 15% or 0.15, but I'm going to have to find that margin of error and get an interval. And also, my confidence level is 95%. Okay, so moving on to the plan step, we're going to identify the appropriate inference method. So we have to name the procedure. Again, I have 2 samples. So this is a 2 sample, but it's for a proportion. So it's Z, and it's an interval, not a test. So 2 sample Z interval for P1 minus P2. Now I have to check my conditions, and this is exactly the same as what we just did for hypothesis tests. So like I said, on your homework, whenever you're asked to do a hypothesis test and then a confidence interval, at this point, if it were the same situation, and if we were doing this for the proportion of Black and Hispanic females, we could just say conditions already checked. Unfortunately, I changed the problem, so now I have to do it for this situation as well. So first, I'm going to check the random condition. I believe it says I have a random sample of 200 US females. And then it also said that I have a random sample of 150 US males. So that random condition is met. I want to check and make sure there's no connection. Is any one of these females connected with any of those males? It doesn't say anything about that, so I can assume that there's no connection between them. These are independent samples. Okay, we'll get into dependent samples in the next part of chapter 2, which will be after the chapter 7 and 8 test. Okay, so the second condition is that 10% condition. So I look first at the first sample size of 200. Is it less than 1/10 of the whole population? So of all US females. Okay, so I multiply 10 by 200. 2,000 is way less than all US females, so that's definitely true. And then I check for the males. N2 is 150. Is that less than 1/10 of all US males? Okay, again, 10 times 150 is 1,500. That is definitely less than all the US males. So those conditions are met. And then finally, I have to check the normal or large counts condition. And this is where I have to do that set of 4 multiplications, or if they're nice, they've given it in the problem, which in this case they have. So I'm looking for the number of successes for the first proportion. So the number of females who use Twitter, right? If I did 200 times my 0.55, I would get 110. And then I have to do N1 times Q1 hat. So this is the number who don't use Twitter. Well, if 110 do, 200 minus 110 would be 90 don't. And then I have to look at the second sample, N2 times P2 hat. That's going to be the number of males who use Twitter, which they told me was 60. And then N2 times Q2 hat. This would be the 150 minus 60, which again is 90. So 90 do not use Twitter. Again, you can actually write out 200 times 0.55. It is equal to 110, but I don't think it's necessary to write it out in this instance since this number was given to us. All 4 of those I check. All 4 are greater than or equal to 5, so this condition is met, and I can use a normal model to approximate my sampling distribution. Okay, in the next video, we will do the do and conclude parts.